So I want to talk about early warning, essentially, and why that's relevant and required for data protection, how early warning integrates with this conventional security stack, our technology, and also how we integrate with the data stack, if you will, the data protection stack. We hope you appreciate the information we're going to share. So the idea of early warning is pretty obvious, right? Zach talked about ransomware, but really ransomware is an APT now, right? It's an advanced attack, and they're becoming more human, if not more human, more automated with AI, but they're sophisticated. So what we used to see with state actors, now we're seeing is kind of commonplace in the ransomware world. Anna, did any of you go to the RSA conference by any chance? Did you happen to attend the CrowdStrike session? So they had a keynote. They shared a ransomware, like a common ransomware kill chain that got in, moved laterally, spoofed two-factor, escalated the whole nine without writing a single code of malware, just living off the land, just using the OS against itself, Microsoft against itself, right? And that's the trend. So that's that 71% that they're putting out there, and they shared that as a service to the defenders. I'm not, they didn't even show CrowdStrike. It wasn't a product demonstration. At the same conference, at the keynote, Kevin Mandia shared that dwell time's actually gone up for ransomware. It's gone up by a day, from 7 days to 9 days. So, and he alluded to it's more likely because the attack techniques are becoming more stealthy and living off the land and so forth. So the reason we put this this double and triple extortion, because like an APT, a ransomware attack, you should expect that they have you. They have the network, they have your VoIP, they have everything, and they're exfiltrating the sensitive data. That doesn't mean that's all they have, right? And so the extortion is not only leaking, but DDoS and that sort of thing. So that's the nature of the threat, and that forces us to think about, is recovery enough? So the answer is no. If you're committed to protecting data, not just recovering, not just backing up, you have to think about what's your window of opportunity to reduce the blast radius. The window of opportunity is during reconnaissance. And speaking of blast radius, I don't know if you've seen this research Splunk did. They were triggered in a way by Lockbit, who was advertising on the dark web the speed of their encryption algorithm. And they were bragging about 100,000 files a minute, I think, in terms of their encryption speed. And that's really relevant. I did the math based on like what they had in the lab environment. Turns out to be about 18 and a half terabytes a day, right, in terms of the encryption speed. It's very fast. They're getting those speeds because they're only encrypting intermittently. They're only encrypting random blocks, so they can encrypt more at the same time. So the blast radius is huge. So if you kind of parse that out over a 9-day dwell time, you're looking at 170, terabytes of data. It just so happens that the average data in enterprise is about that much. So it's everything, right? All you can eat buffet of data. They have everything. So blast radius huge, mean time to ransom very short, less than 4 hours from point to point to mission accomplished. Your window is right here in this 70 minutes or so of breakout time between the time an attacker gets in and the time they get to lateral movement when they're doing reconnaissance. And that's where we decided we needed to be in terms of early warning to help security not just contain, but to bring recovery left, if you will. Think agile versus waterfall. You can even have a blast radius of all the data, or you can contain it and have a micro blast radius or smaller blast radius or none at all. And the only way you're going to get there is by seeing the attack early. So if you think about mean time to detect and correlate to mean time to recovery, a minute, when you consider how quickly this thing moves, is precious. All right, it's a very valuable minute. Does that make sense so far? All right, so that's the space we're in. So how do we do it? The mission is to defend data sooner, see it in this landscape of advanced attacks, and LOL bins is suddenly getting a lot of attention. I mean, they've been around, they've been exploited since 2015 or sooner. But they're getting a lot of press lately, particularly like Microsoft issued a blog about a month ago about Volt Typhoon, a state actor who's doing reconnaissance in North America and Asia Pacific, and they're living off the land. And they called out Run DLL 32 as an example of an LOL bin that's getting exploited. So at Commvault, we eat our own cooking. We have our own technology in-house. We start to look at that and go, really? So we ran tests with Endpoint. This is just an open source endpoint tool. That's not what we use. We use a leading commercial endpoint tool. But we tried it against 3 different endpoint tools, and we ran these LOL bins, and they collect the information, right? But they don't alert. How are you going to alert on Run DLL 32? You can't. I mean, you need Run DLL to run Windows, right? So you can't, you collect the information, it goes into the data lake, you can't alert on it, or else unless you love false positives. If you love false positives, you alert on LOL bins, right? And you'd get millions of them. So it really puts these tools that collect data and use AI to discern good behavior from bad behavior in a box, because really this is not bad behavior. They're not introducing foreign files. They're not exploiting vulnerabilities in a lot of cases. They're just using these tools and getting these nefarious outcomes from them. We don't have that problem. So we have a different technology. We don't put agents on endpoints. We don't collect data on endpoints. You have tools that do that, right? We're not collecting logs. We're not scanning networks. What we do is we put fake assets in the environment. Deception, right? And with this technology comes out of Israel, no surprise. It comes out of the Israel Air Force network defense. It's literally battle tested for 10 years. It's incredibly effective. And the secret to this, now, honeypots have been around for a long time, right? 1997, right? This is the reason this is different. It's very modern. It's very lightweight. So someone wants to play along. I'm going to pose a hypothetical, right? Do you mind if I pick you? All right. So say I'm in a field. Pick the size of the field, right? You said British. We'll do British units. 50 yards long. I'm an attacker. And there's no question, like I'm so skilled, you have no chance of defending against me. And I'm running after you. And your only defense is to put landmines or traps in front of me. How many would you put in front of me?
As many as I had.
As many as you can, right? Where would you put them?
Around me.
Yeah, wherever you think I might be, right? Okay, fair answer, that's what I'd say too. What if they cost $100,000 a piece? How many would you throw out?
Depends on my budget.
Depends on, am I going to kill you? Am I going to hurt? Now you start doing these risk equations. What if they're cheap, but they're really heavy?
I need my workout anyway.
Yeah, But so the point is, like your gut is, I'd throw as many as I could, right? That's your impulse. Of course you would. No risk. I'd throw as many as I could. But then when I introduce cost and weight, now you start playing the risk game. Well, it depends on how badly I'm going to get hurt. I'm not really sure I can afford that. If I can only throw 2, I'm not going to do that. This technology solved that problem. So, and that was the problem with honeypots. They're a good idea, but they're heavy. They're expensive. They're risky, right? Because you're introducing an actual vulnerable asset. You need skills. You need to watch it. There's certain baggage that came with it, and people kind of put it in the corner saying that's for labs. That we're not really ready for that. So what this technology does, the backbone of this is they create these lightweight sensors. So think of them as microservices. So I'm going to dwell on this slide for a little bit because it's the closest thing I have to an architecture slide. So what we do is our management console is hosted in the cloud. It's a service, right? And you buy these sensors. You buy and buy the sensors, many as you need. Buy them in 10 packs. But we deploy through a container. So we deploy through a virtual appliance. And you configure, like say, a Windows 2000 server as a service in the container. So this container is light. It's a VM. So it's like 40 gig of disk. You know, it's a small footprint. And you deploy this virtual container. And you configure these sensors. Now, the cool thing about this technology is a virtual container. You're not putting anything on endpoint. So we can deploy in a hospital room, a lab, manufacturing floor, IT, We have these things in copper mines. We have them we have them in renewable energy, in the grid, and in IT, and in retail, everywhere, because they don't touch anything.
It's a VM, it's a container.
It's a VM or a container.
Yeah. Can you clarify that? You said Windows 2000, which sort of takes me back.
It could be anything. So what
The
you
container is Windows
No,
2000,
no.
or the sensor emulates Windows 2000?
correct, the second,
Okay.
right? So what you can do inside of that container, you can configure up to 500 different assets. It could be a router, it could be a switch, it could be a camera, it could be a blood gas analyzer, it could be, we have a library of them. We'll also scan and take a fingerprint of what you have. We have a company, a consumer packaged goods company that has turbines with IP addresses, right? They have fake they're considered DDoS or ransomware. They're target manufacturing, huge target for ransomware, right? So anything with an IP address you can emulate. And the emulation is a deep enough interaction to identify the attacker, their MAC address, their IP address, what they're doing, and how they connected. So it'll detect scans, it'll detect connection events, it'll detect some interaction. Enough to catch the guy, enough to identify and catch the guy, and catch the actor.
So it mimics, say, Windows 2000, meaning that.
Or Linux or whatever, yeah.
So you open up fake ports, when queried, you respond.
You set up
similarly.
services like FTP or RDP.
Stack
Exactly.
fingerprint would be fingerprinted as that OS,
Yes.
presumably.
Yes.
So at that level, it mimics that.
Correct. And they can only be seen by the attacker. So legitimate people, legitimate systems don't see it, right? So
Meaning that if I've
you have to
randomly-
whitelist it, right? So like we would pick up vulnerability scans, right? We would pick up like legal scans.
Sure.
So as long as you have your act together, it's very, very quiet, very passive, right? Because we're not scanning things.
And you're not broadcasting and saying I'm here.
No. Yeah. Right. So the emulated. So what our customers did. So we did it for time to value. It was really interesting. So what our customers did though, because you can deploy like 250 of these in a day, and that's the conservative number because you just configure and there are templates. We can scan. You can do it. You can do it in bulk. What our customers do is they cover a lot of surface area. They hide in a crowd. So some of our customers will cover 30% of their surface in these sensors. So now they change the math of the attack. Now the attacker has to guess which asset is real. And that includes backup infrastructure, media servers, anything along the kill chain. So it could be in a branch office on a printer. Printers are pretty handy in attack, right? It could be in a manufacturing floor, like I said, or it can be in the core data center, and you can choose the density you want. And so they're buying time. This is the only technology, in my opinion, that I know of. Wait a minute, I'm gonna pick one. In my opinion, it's the only technology that buys you time. Because by definition, everything is collecting data on something that's already happened. This is interacting in real time and it slows the attack down, okay?
How faithful is the emulation, the mimicry, right? So if maybe you'll get to this later, but I'm thinking about someone who lands, plants malware, and then pivots.
Mm-hmm.
So let's take a Windows.
I can show you. You want to hold it? I can show you.
I don't want to take you off track, but
No. It's native. The only time it's not faithful is if you're not following best practices. So if you don't name it with your naming conventions, as long as you're smart about blending it in, naming conventions, services that are open and things like that, you can't tell the difference. It's
so
native.
I'm Mirai, and I fish you,
Mhm.
and I get malware on a VM.
Mhm.
Say it's someone running Windows 2000,
Mhm.
which would be easy to
Yeah.
optimize. But what I really am after is I'm after longevity there, so I can pivot to your directory,
Okay.
your Active Directory environment. Can you set up a combination of
Yeah.
these sensors
Yeah.
so
Yeah.
that
Okay.
that's detected?
Great question. Okay, so let me tell you about the rest of the architecture. So the answer is yes, and here's how we do it. Now, the emulation, like I said, the trade-off is what you get. The pros you get is surface area coverage, lightweight, speed, agility. What you don't get is deep interaction, right?
You don't get the depth, right?
Correct, right. So like an emulated sensor wouldn't pick up run DLL32, right? But the full system does. So that's on the bottom, right? So that is actually a VM another appliance of a full stack, whatever it is you want, it could be a web app, right? So, and it could be set up with vulnerabilities and so on and so forth. That's the deep interaction. Now, the interesting thing is you can proxy them. What that means is that if I wanted to put, say, 50 traps in a VLAN, I could put, or sensors in a VLAN, 49 of them could be emulated and one of them could be full and they proxy. So all 50 behave like a full, right? You get full interaction. So if I do a scan and I've got 50 IP addresses to choose from, whichever one I choose will have the full interaction effect, and the full system's smart enough to parse out what emulation the interaction's coming from. So if I want to pick up on run DLL32, I'd put 50 out, I'd have one full system, right? And then I'd collect all that data. Now there's always a chance, even let's say with 50, you've got 200 other assets potentially in the segment that they could hit a reel, and that's where the lures come in. So they come in a lot of different ways. So a lure is an artifact. It's they get deployed on the endpoint. It could be a cache credential. It could be bookmarks. It could be, it leads you to the sensor. So so you're creating this fabric basically around your assets. You're registering your assets in AD, right? So if an attacker gets in and they don't do a scan, they're just querying AD, they would find these servers in the server groups and they go connect to them and you've got them. You could have fake users, you could have fake credentials. So if I'll show you an example of Run DLL where I actually cache credentials, right? I steal cache credentials and use it in an attack, but they're fake credentials and it leads me to a trap and I get the telemetry on that attack, right? So all of these things work together. It's all through a single platform and you pick it like, we say Windows, because we put Windows, we come like out of the box with a Windows 2000 R12 because it's so vulnerable and it's.
So sorry to hear that.
But it's like, it's candy. Like, so we put that as a default, but we've got a whole library of controllers and assets. Does that make sense?
Is the maintenance of that, right?
Yes, yeah.
Do you put that in the domain servers? Do you actually register as a real machine?
Awesome question.
With that,
it's a great point.
With attackers, we've seen they come in, they realize IP change unless you can re-IP the target system on the fly. You realize that it's changed out from under.
Yeah.
Right, and then, historically with some of the other players in the space around this, like Canary, Calvio, right? All those.
Yeah. Where do we put them?
Yeah. Where do you put them, and how real do you want it to be?
Yes.
How real can you change the target system?
Yep.
And it's OS specific. And I worked with one of these back when, where the Windows image had to be near final, and then they would try to invoke it to finalize it with the appropriate identity of the system as you will bring the attacker in, and that's a lot of hassle, right?
Yep.
That's a lot of hassle.
So we got the same feedback. So I was in a CISO roundtable in Tel Aviv, right? And same feedback, right? So that's there's a roundtable, right? There wasn't the room wasn't full like for any people like stepping out every 3 seconds, getting phone calls and whatnot. But anyway, that was their feedback to us, faithful customers. But they were saying, this is really good. It's easy enough. Can you make it easier? Like how can you, we don't want to try to figure out what sensors to put in and where to put them.
Right.
Well, this is where the beauty of the backup infrastructure, who knows more about the infrastructure than the backup, right? They know the profile, they know the value of the data. That's where this integration comes in. It informs where the trap should go. We're the only technology that does that. If you come in from the endpoint, an endpoint's an endpoint. If you come in from the network, now, the thing is, even if you do a fair assessment it starts at crown jewels, it starts at the data anyway. Then you start to think about the attack path to that data. So we have the best view of where the trap should go because we know where the crown jewels are, right? So I love that you asked that question because that was kind of the vision we're thinking of. I think I can say this. Yeah, I can say this because they're a customer, but an Iron Dome for data, right? And that's the idea. It's not shooting down every rocket. It's looking at the ones that are going to hit a valued asset and having that telemetry to know where the risk is, so you can contain the attack.
Or redirect the rocket to take assets.
That's right. Backup. Right. All right. So here's the point of this demo is to show you how we'll run, so we're running a run DLL on shell 32. I don't know if you're familiar with shell 32. Use shell 32 to open up websites and files, and it gets used to gain persistence and so forth. Okay, so let me run the demo, and this is pretty quick. So here I'm opening up, this is a compromised machine. Assume I have command and control. So I'm going to pause on it. You can see the run DLL 32 command. Right, and it's just validating that it runs. And notice the EDR in the background, nothing to see here. Same thing with no viruses. No, there's nothing to alert on. Right now, it's not as though this technology is not picking it up. It's just not alerting on it. Right, for the reasons I mentioned. Okay, but here's what we did. Something kind of clever. I hope I'm still running it. Let me see. Okay, good. We see here, we will show you, we put a remote, we put a remote desktop connection on that endpoint, right? So the attacker's in the compromised machine, they go, oh, look at here, they're doing reconnaissance, they find a remote desktop connection. That connection is a lure to 1.137. Okay, if you see that. 1.137, guess what? Is not real, right? And so they run the same command, right? Run DLL on shell 32.dll, right? On this endpoint remotely, they connected via RDP, and we found them, right? So this is immediate real-time interaction with a sensor, and we're alerting on it because they're interacting with a trap. And so if you could see this, I'll run it a little bit, right? There's the IP address 137. Can you see that? That's who was attacked. This is the timeline. This is how they connected, right? And you'll see the run DLL when I cascade down a little bit. There's the run DLL command, and that's what we alert on. Now, this is what you hunt on. So this is how it's complementary. So we have the attacker IP address, the attacker MAC address, what they did when they did it. This is the timeline. This could be your recovery point. This is when we see activity. So you take this data, you pivot to SOAR, and you go hunt in that data lake for that MAC address, that IP address, and those techniques. So we write internally, we write filters for if you're seeing run DLL 32 on comm service DLL, then we go look for that MAC address. We're not, right? So we take the needle out of the haystack, boom, here you go hunt on it, and then it really reduces your alert volume. That becomes your high fidelity alert that this is highly, highly likely that's a bad actor. Make sense? Okay, so that was one demo. Next demo is we're actually going to compromise an endpoint, a real one, right? They're going to run comm services DLL. This is the technique that was highlighted in the Microsoft blog. They're going to do a dump of comm services DLL. I'm going to show you how we address that. So same thing. This is, I don't need to pause. You'll see it running, right? It's run DLL on comm services. I'm going to do a mini dump, and you're going to see there's going to be a dump file called test5, I believe. Give me a sec. There's test5, right? And now, of course, the attacker's got the file. They're going to pull it out outside of the network on their machine, right? Which is what they're doing here. Now it's on their machine. No one can see what they're doing. And they're going to run Mimikatz on this, outside of the network. So now they're going to take that file, dump those cache credentials, which we put on the machine. They're fake credentials, right? So when they dump those credentials, they put it on the machine. You're going to see they're going to run Mimikatz. I hope you can follow this, right? And you'll see there's the file they took. They're going to add test5. Boom. Okay. I sped up Mimikatz. You'll see, right? Boom, I'll stop. BAMF user 192.168. So there's the resource 1.230, right? There's the whatever server, right? There is the user, there's the password. So they cracked the password, they used Mimikatz, now they're going to go conduct an attack with those credentials.
So we didn't flag them on the exfiltrate?
It's like one text file.
to do so.
I think that would be typically if they do exfiltrate, it's going to be a file like that. That would be really hard to pick up on. No, we didn't flag anybody on an exfiltrate.
Okay.
If it were like volume, like a DLP or something like that, would pick it up. But if you're taking one file out, I had, and this, it's common, right? So in this case, I won't go through the details, but they're running PSExec. They're connecting. They're using the credentials. They're connecting now to a host machine, and they're going to run an executable on that host machine using the credentials that they stole. What they don't realize is that they're connecting to a fake host. So any one of these things, if they happen,
The lure was the credential.
the lure was a credential. Yeah. So we redirected them to this asset, and it's the same. You'll see the same pattern, right? We pick it up. In this case, they're running an executable. You flag on that, but we track back to the host IP address. So if they get in, they do an ARP scan and they find us, we'll alert on the ARP scan. If they decide to connect to one of us, we'll alert on that. If they connect to a real asset, the lure will bring them over to it. So you're just switching up your risk exposure, right? You're reducing your threat event frequency, essentially, right? Because you're attacking a non-machine versus a real.
And your clients, when you said
So this is Steve here. I'm trying to wrap my head around what you're doing here, where the real machines are in the network and where the canaries are. Because I'm confused when you're bouncing back and forth between them.
Yep.
So when you say there's a lure on the real machines, you're somehow distributing to regular domain computers these lures of fake credentials.
Right. So what we do is when we create the sensors, we decide the software will prompt you if you want to create these lures. And you do, and it'll create an executable and use like SCCM or something like that to distribute them. And then they would lead you to these fake assets, right? So you should probably register them in AD as a group, because if I'm querying for users in groups or server groups, if you're not scanning and you're querying AD, you're going to see them. So in both cases, what we did, I think it's Steve, is what we did is the first demo we showed, look, we attacked an endpoint, a real endpoint. We showed you the EDR, there's nothing to alert on. They don't alert on it. Then we redirected the same attack over to a fake and showed you that we alerted on it. That was the demo. So it was the lure was a lure. We just showed you, like, look, if you attack it this way, you don't see it. If you attack a fake one, we do alert on it, right? And then you use the telemetry on the fake to hunt. So you would use SOAR or something like that to hunt on that. To make sure to increase your odds, you'd put lures on the real endpoint. So if they do hit a real, you'll redirect them to a fake. It just increases the efficacy, right? It increases your odds. All right, I got 10 minutes left. And then, thank you for that.
Okay, so if you have a normal attack scenario where I've phished a real person's credential, I've taken over their real machine, and I have their credentials. So I use real credentials from the real AD on after scanning one of the canaries. What happens?
Yeah. If you're using a real credential to connect to, when you mean canaries, you mean a honeypot, right? Or
the honeypot.
The honeypot, yeah. So if you're using real, and this is actually a really good point, because this could be insider threat too. And the weird thing is hard to tell which is which, right? So
I'm just saying most of this stuff comes from phishing, so they've got real credentials.
Right. Or you can buy them. Like, you don't even have to phish anymore, right? You can just go to a connection broker and buy them.
Or you could just ask someone what their password is. Hand it right
Exactly.
over.
Yeah.
Oh, sure.
Exactly. Yeah.
Oh, sure.
Yeah, exactly. Yeah.
The easiest fish of all.
You're right? It could be insider. You wouldn't know if it's insider or outsider because they probably have credentials. They probably buy them anyway. If you want to fish, go ahead and fish. The point is, they're real credentials. If they're interacting with a decoy, that should still be an alert. That's an incident because that individual does not see that asset. Like, they're not doing scans, they're not connecting to them, they serve no purpose. So that's still like worth investigating. That should be a high priority incident, even if they have legitimate credentials. And by the way, that second example, when they ran Run DLL on comm services, those should be real credentials. So I got on, I want to move laterally, I'm looking for credentials, right? As an attacker, I think those are real. How do I know, right? And we just use those to redirect. So either way, any interaction with one of these things is a high fidelity alert, right? It's it's in the high 90 percentile that it's not a false positive.
So one of the false positives now I'm worried about as a data person is that I'm often running tools and scans to discover data that we don't know about, to discover resources. Like legit, I'm not doing security work. I'm inventorying, cataloging, adding. So is there a way to keep my scans?
You have to, or else it gets really noisy.
Yeah.
So we do have a utility where we'll show you, we have like a whitelisting or a tool that will show you, here's what's scanning us. And that'll feed your whitelist. So that keeps us out of scope of your scanning tools. But it also, once you cycle through that, it'll also show you rogue scanning tools that shouldn't be in there. That you could have an employee using a unsanctioned scanning tool. So
just because he's trialing it.
Yeah, and that's worth responding to either. But that's the best practice. You got to get that stuff out of the system.
So my job as an insider malicious attacker is to get on the team responsible for cataloging, get whitelisted, and then go do all my work.
Yeah,
I'm being facetious, but yeah.
That's a good point. Once you whitelist a tool that is legitimately scanning, how do you detect if that tool gets hijacked and is then doing malicious activity?
It's hard, isn't it?
That's toughy. Yeah, so you're like a supply chain SolarWinds-ish type of deal.
Or you whitelist it so specifically, like I'm expecting SNMP from this host, but if I get SSH scans, alert.
You could do that. Yeah, same thing. Like we would give you the connection type, time of day, where it's coming from, and that sort of thing.
That's what I wonder. Like now I want to go back to my team and say, I want to tell you when I'm going to be doing this as much as possible so that you're not just whitelisting me, you're whitelisting my process from my team.
We even did this, I didn't mean to butt in, but we went into well, they're now a customer, but then they weren't. They were a large infrastructure company in Latin America that like classic ransomware. Like I don't even, this is textbook. And we went after to do forensics because there's no telling, they don't know if they're still in the environment. And we were seeing that their vulnerability scans were failing. So the vulnerability scans were hitting our assets. Our assets were vulnerable, but they weren't responding. So it was uncovering like flaws in their vulnerability processes. So typically these signals will go through syslog into a SIM or a SOAR, right? But we also have visualization tools where we can see lateral movement.
Just a little bit about the architecture of the deceptive assets. Can I call them Decepticons?
Sure.
Decepticon.
Can you describe those a little more? What prevents those from being compromised? Are they hardened in any way, or do you redeploy them daily, or like what protects?
Good.
They need
they're hardened. They're CIS hardened. So they are hardened appliances. Our customers demanded that, right? So they're CIS compliant. They're about as hardened as so it has all of the rules of zero trust inside of the appliance itself. Do you rotate them? I don't think you necessarily rotate them. Now, the appliance itself, so I think you get it, is the emulations, you can't pivot on an emulation. There's nothing to pivot on, right? So you're right, it's the virtual appliance. So the best we can do is harden it. The TSOC is off-prem and that's air-gapped, and so it would be very difficult. It's in the metallic environment, it's highly secure. It'd be very difficult. Nothing's impossible, right? But it'd be very difficult for an actor to gain control of the command center, of the control center that's outside of the environment and that's air-gapped in the metallic environment. Does that answer your question?
Yes, thank you.
Yeah. I had someone ask me, and I love it because I love the line I came up with. That's why I'm doing it. But I said, can you guarantee that an actor will connect to a trap, right? So I say, that's a trap. It's like, there are no guarantees. So you can't, right? It's a risk, right? So you reduce the risk. I said, but what I can guarantee you, and you don't get to do this very often, is if you don't have deception, 100% of your assets are real, right? So an actor gets in, there's low risk, they get kicked out, they learned, they go back, they get kicked out, they learn some more. There's no risk virtually, right? This wastes their time because it is a race against time. It's a race against time for us to defend, but it's also a race against time for them to attack. They don't want to spend a lot of time on the attack, and this wastes their time. All right, so one more thing. This is a visualization tool. If you take a look at it, you can start to filter on things like time, because now you see these little bad guy symbols, right? These toxic symbols. You can see they can bounce from one IP to the next. It's kind of hard to visualize lateral movement, but you can look at like a time range in a segment and see what's happening during a certain time range, and what these are the sensors that these actors are attacking. So it can narrow it down. We just did it for the demo. I sped it up a little bit here. These are the things that actually got attacked. You see the 143 was one of the assets, and then obviously you can click on that and again get back to the telemetry. So it's a way of visualizing that if you so choose. Okay. Now the points I want to pick up is we see things that that other tools can't. It's complementary to those tools. So we take the needle out of the haystack. I'm sorry I'm using that analogy, and you hunt on that needle, and then now suddenly you go into the data that you have, and you can hunt on it. That's simply a matter of writing sim rules. What else was I going to say? Lightweight, plays in any network. We give you all the signatures and timestamps for not just detection but recovery, and that's where this gets to. So the really interesting thing we're doing now with the data stack is it's informing where these sensors should go, right? The backup environment knows the value of the asset. The backup environment knows the profile of the asset. So it has the map, basically, of where the crown jewels are. And what the ThreatWise advisor does, based on some basic risk calculations, will recommend a certain number of sensors around that asset. So if it's a tier 1 asset, it's in an important segment, it might recommend 3. If it's on an edge, it might recommend less, because these things, they give you early warning of early signals of attack, but they also buy you time and hide in a crowd. So it's not the same density for every asset, for every segment. But so what happens is when we scan a segment, we classify the asset, we recommend traps, and the advisor sends that information to the deception console that'll deploy the traps. And every time, you talked about keeping it relevant and keeping it fresh, every time that segment gets scanned, the list gets updated for the ThreatWise security. So this addressed what our customers are asking for, to make it easier. But then if any one of these fakes, if any one of these alerts, they're relevant to the asset that's being protected. So that'll trigger runbooks for the backup environment, right? To stop aging, to protect the backup infrastructure, to protect the data, but also to recover to that recovery point, as well as to security. So you get kind of these alerts and early warnings, both to the backup administrator for the data and to the security, to the SOC to contain the attack. Does that make sense?
Yeah, I just want to clarify before you go that the alert doesn't do a back. It doesn't. I'm a little confused. You said it would back up the asset. What you really want is you want the asset not to be poisoned. Right.
Right.
Do you know what I mean? You want to.
Yes. So
you may not want to do a restore either at that moment.
You're right. So what I'm going to do, if I'm an attacker, I'm going to compromise a production system, but I'm also going to take your ability to recover it away. So I'm going to attack the backup, and it all happens kind of all in one ball of, hate.
Sure, a race against time, because I have to encrypt everything.
It's all happening. So I'm going to take down your ability to recover. I'm going to attack that endpoint. I'm going to crypt it. And I'm going to exfiltrate it. It all happens like very quickly. So our response is we identify. So when we make the connection between the production asset, what we're backing up, what it looks like, and what the alert means to the backup environment, because all at once we want to alert security to contain the attack, but also alert the backup environment
not to do anything.
Not to do anything, and to protect your backup environment so the backup doesn't get taken down, right?
Yeah. That's timing critical.
Yeah.
So how do you make the link? I'm sorry if I missed this. How do you make the link between the lure and the production asset?
The lure is on the production asset. The lure.
You have to put the lure on the production asset. I can't have that. That's not a honeypot, right? At that point.
No, that's a.
So you wait for the guy.
file.
You wait for the attacker to pivot to the production asset where there's a lure.
No, you don't have to. Like I said, if you got, say, 200 assets in a segment, right, or at a VLAN, 50 of them are fake. 200 of them are real. Did I say 200? 150 of them are real. 50 are fake. They could hit a fake or they could hit a real. If they're going to scan, you're going to pick up the scan event because they're going to scan the fakes and you're going to get early warning. If they're using AD and they're navigating around and they happen to hit a real and not a fake, right? The fake doesn't know, so we create a lure to draw them to the fake. So, like I said, if I'm using Active Directory and I go into a server group and I get onto a real server, nobody knows. And if I'm using LOL bins, nobody knows what that actor is doing, right? Not EDR, not even the fakes, right? So we put lures on that. So when they're doing that LOL bin, they'll find artifacts that they can go chase that'll lead them to a fake. That'll give them that alert. So lures just make it more attractive. It's road signs, breadcrumbs, whatever, to kind of drive the attack toward a fake. You don't need them.
Protect the
It's
backup
more effective with them.
environment on a lure. You can protect the backup environment on an alert from the lure.
No, the alert doesn't come from the lure. The alert, for us, the alert comes from the fake asset. The lures bring you to the fake asset.
All right.
Right. So you've got, and the team will bring you into we've got more functionality around the real endpoint, like, file anomaly detection if there are other controls on that real asset that we have too. But for this early warning system, all the alerts come from the fake assets, the honeypots.
Has there been customer feedback about allowing a lure or a more advanced lure to throw an alert? I know that there's a very popular company in the industry that does something very similar.
Yeah, we're working on that. Yeah.
Because I think that in order to play in that market, like Alex kind of said, I don't want the lure to send them to somewhere where I can trap them. I want to know the instant they hit that file, because that could be.
Yeah.
If you're dealing with a sophisticated attacker, they may be smart enough to kind of look at things and go, I don't trust this system, so I'm going to stay out of it because this is my target.
Yeah. So it's a good question. So there are two answers. One is we have a honey file that Commvault has that would detect bad behavior on the file. And then we have it on our roadmap to create more intelligent lures.
Okay.
And that's on the roadmap. So yeah, that is an ask, and that's in the works.